Hey, in this video, I wanted to talk about the redox reactions. So the basics of the redox is that the redox is type of reaction that has both oxidation and you also have reduction. So oxidation is, if you remember, I mentioned the charges in my previous videos. I said that charges is this portion, right? You might remember me saying that the first group has +1, second group has +2, third has +3, and so on. So these are the charges, right? So when you get more positive, right? If such as if you go from +1 to +2, or if you go from +2 to +3, or if you go from +1 to +4, you're increasing by the charges, right? In that sense, you're oxidizing, right? And then for reduction, you go the opposite. Like you step down from the charges, right? If you're +3, then you go +2. It would be reduction because you go from more positive to less positive, right? Okay, that's the basics. So what if I ask you what is what happens here? Well, if you follow along with error, you go from +2 to +1, or 2 plus to 1 plus. In that sense, we decrease our positive charge, right? We went from plus the bigger positive charge to smaller positive charge, so it should be reduction. Okay, what about let's assume some, so x plus, so this is just an assumed element. What about x3 plus? Is it oxidation or is it reduction? It's definitely oxidation because you're going from less positive to more positive, right? Okay, now since you know the basics of oxidation and reduction, let's do some question. So so when you're doing the redox reaction questions, first of all, again, I'll repeat, in the redox reaction, you're gonna see oxidation and reduction happening together, right? So I'll draw a redox reaction, but before I do the redox reaction, I want you to understand one thing. So whenever you see something by itself, such as you see oxygen, O2, or you see Cl2, or you see Zn solid or whatever. See, it's the same type of the element, right? Like oxygen has two oxygen, it doesn't have anything else. Here, chlorine has chlorine and chlorine, it doesn't have anything else. Zinc has only zinc, nothing else, right? Whenever you see this thing, it's always going to have a zero charge. Make sure that you don't forget it. Okay, now I'm going to draw my first redox reaction equation. So HCl aqueous Zn, this is not goes to, this is plus H2 gas plus ZnCl2 gas. Oh, aqueous, sorry. This is aqueous, the last thing, the aqueous. Okay. Before I start, I want to let you know aqueous means that something is dissolved inside water, and then solid mean it's solid, right? You have that's it's present in the form of a solid, and then gases, you know what a gas is, right? So here. So if you can go back, let's focus on this. So if you go back to the periodic table, what should be the charge on Cl? So it's in the seventh group, right? And you all should know that this should be -1. And we all know that hydrogen is +1, right? So let's write down the charge. -1 +1. Okay. What about the zinc? So as I said, zinc is by itself, right? Here, H is with Cl and Cl is with H. So nothing is zero. Nothing is by itself, right? They're together. But Zn is by itself, right? So in that sense, it should be a zero. Okay, what about here? Again, look at H2. So H2, but H is by itself, right? It's two H's, it's nothing else. So again, we're gonna get a zero here. What about ZnCl2, right? Okay, now what is the charge on Cl? we know that it's in the seventh group, so it should be -1. But here we have Z and we have two CLs, right? So in that sense, when you get a two here, and it's going to be a one here, so overall, like you have two CLs, like one CL should have one negative charge, but since you have two CLs, so of course you're going to end up getting two negative charge, right? So this whole thing is going to be two negative, and now since overall it's neutral, right? I mean, there's nothing that says ZnCl2 should be like this or something like any other charge. It just says like it doesn't mention anything, right? There's nothing here. If there's something there, then it's not neutral. But since there's nothing there, it's definitely neutral, right? You don't have any charge. So in that sense, um, we have the total for here, the S2 negative. So it should be neutralized. Like this should be two positive. That should cancel out this two, right? So in that means if this is one negative for ECL, and then for 2CL it's two negative. So that means for Zn it should be two positive, right? Okay. Now let's see if there's an oxidation or reduction. So look at H. H goes from +1. H goes from +1 to 0. What is it? It's reduced, right? What about Zn? Well, Zn goes from 0 to 2 plus, right? So it's oxidized. Okay. What about Cl? It stays -1, so it's nothing. It's not oxidized, neither is reduced. It just stays the same. Okay. Now, if you go in generally, if you talk about an agent is someone who is basically involved in doing something, right? Not involved, or you could say assist in something. So there's also agents in this redox reactions. One is oxidizing agent and the other one is reducing agent. So oxidizing agent is the one that causes the oxidation. It's not the one that is oxidized itself. Instead, it causes the oxidation. So the one that is reduced is going to be the oxidation state, oxidizing agent, and the one that is oxidized is going to be the reducing agent. So in that sense, H is reduced, so it should be an oxidizing agent. And then Zn is oxidized, so it should be a reducing agent. So before I end this video, I want to mention one more thing. So oxidation isn't just caused by the change in oxidations or the change in charges. It's also caused by the loss or gain of electrons. Loss or gain of electrons. So I'll tell you a mnemonic device which you can use, OIL, oil rig. So basically oxidation is losing electrons, right? And reduction is gaining of electrons. So hopefully it all makes sense to you, and thank you for listening.